Shear and moment diagrams. So first, let's define beams. So beams refers to slender bar that carries transverse loading that applied forces are perpendicular to the bar. So beams, ito yung tinatawag sa Tagalog na biga. Yung mga naka-horizontal na reinforced concrete, sila yung nagsusupport sa mga slabs natin. Usually, ito yung mga nakikita natin sa taas ng mga posts or poste. So, before po ako mag-start sa mga problems, I would like to identify muna yung mga common types of beams na makikita natin. So, ito po yung 3 common types of beams, which are the cantilever beam, simple beam, and overhanging beam. So, first is the simple beam or the simply supported beam. Yung isa niyang end is usually pinned while the other end is merong roller. Then yung pangalawa is the cantilever beam, which is yung isang end niya is no support or free end. And yung other end naman is fixed ended. Then lastly is the overhanging beam. Yung beam naman na to is parang ano lang din siya, simple beam, pero meron siyang area na naka-overhang or meron siyang naka-extend na portion. So these types of beams are yung mga tinatawag nating statically determinate beams, which means that the value of the reactions can easily be found by using equations of equilibrium. So we also have what we call the statically indeterminate beams. The first figure is the prop beam. So, or the prop cantilever beam, which is yung one end niya is naka-fix while the other end naman is naka-roller. Then another example is the restrained beam or the fixed beam. So, yung parehong end ng beam is fixed or fixed-ended. Then lastly is the continuous beam. Ito yung mga series na ng beams which is supported sa both ends nila. Then sa mga specific points nila is mayroong mga rollers. Problem 1. So this is our example. So this is our example. Ang gagamitin natin dito is method of section. So we need to draw first muna yung FBD para ma-visualize natin yung figure. So this is the beam. Yung one end niya is pinned while yung other naman is naka-roller. So basically, this is a simply supported beam. So may load dito na 12 kilopounds. Then dito naman is 10 kilopounds. Then meron siyang distances which is divided into 3. 4 feet, 8 feet, and 9 feet. So A, B, C, and D. So usually mas prefer na i-draw yung shear and moment diagram below the loading figure. So dito yung shear diagram, then underneath naman is yung moment diagram. Since ang gagamitin natin is method of section, so ang first step natin is to solve for the reaction. So dito sa pinned end is A vertical. Then dito naman sa kabila is tatawagin natin D vertical. Ang A horizontal natin is 0 since wala namang horizontal forces na nag-exist, kaya 0 na siya dito. So we only go with the verticals only. So let's consider yung D. By taking the summation of moment at D equals 0, clockwise positive. So ang A vertical natin is multiplied by 4 plus 8 equals 12 plus 9 equals 21 minus 12 times 17 minus 10 times 9. So 12 times 17 plus 10 times 9 divided by 21. So ang makukuha natin is 14 kips. Then dito naman is summation of moment at A equals 0 positive. So dahil dito ay counterclockwise siya, then dito ay clockwise. So 12 times 4 plus 10 times 12 minus dv 21. So 12 times 4 plus 10 times 12 divided by 21. So ang nakuha natin is 8 kips. So pwede natin siyang i-verify using the summation of forces vertical equal to 0, which is AB plus DV minus 12 minus 10 equals 0. So para makuha siya is isa-substitute lang natin yung una nating nakuha na AB, which is 14 plus DV minus 12 minus 10. So ang makuha din natin ay 8 kips. Pero mas advisable pa rin na gamitin yung summation of moment para masabi mga forces, since kasi dito, pag dito kasi nakadepende lang tayo dun sa nakuha nating reactive force na una. May mga time na sa una pa lang mali na, so mali na rin yung susunod na calculation. Unlike sa summation of forces, dun tayo nakadepende sa mga given, so most likely mas okay siya gamitin. Then, yung next step is puputulin na natin siya into segments. So, ito yung mga segments, yung A to B, B to C, and C to D. So, then gagawa tayo ng equation of shear and moment. Ang gagamitin natin segment ay A to B. Ang gagamitin natin ay ang segment A to B. So, meron siyang then dito yung 12, then dito yung 10. Since A to B yung gagamitin natin, so dito lang tayo magpo-focus. Starting from the left end of the beam, magkakat tayo at any point between A and B. So, nakadepende sa atin kung saan natin ikakat dito. So, pwedeng hanggang dito. So, ang lalagay natin X distance from the left end. So, kung consider natin yung left side, so ang merong force lang dito ay yung 14 kips. Ito, 14 dito. Nakuha natin kanina. Then, dito po yung 8 kips. Then, dito sa pinutol natin na to, dito na natin makukuha yung shear and moment. So, para malaman if kailan naging positive and ang moment, kailangan din natin malaman kung naging positive ang shear. So, ito yung beam. Pag pinutol mo siya, magkakaroon ng left and right. So, dapat yung left side natin ay, para makonsider na positive, dapat ay naka-downward siya. Then sa right side naman is upward to considered as positive. So dahil dito ang pinutol natin is from the left side, ang ko-consider natin is downward para maging positive. Then yung moment natin is pa-counterclockwise. So ang kukunin na natin is yung equation ng shear and equation ng moment. So this is the distance x na nakuha natin dito, pero in-isolate lang natin dito. Para makuha yung equation ng shear is by taking the summation of forces vertical is equal to 0, considering upward forces positive. So magiging 14 minus b equals 0. Ang vertical equation natin is 14 kips or 14 kilopounds. Then for the moment naman, we take the summation of moment dito sa kinat natin. Dun sa cutting point is equals to 0. Ito, equals to 0. Considering clockwise moment positive. Kaya 14 kips equals to 0. Then 14 kips times x minus m equals 0. So ang moment natin is 14x. So for segment B to C, so same lang din, kukunin natin yung shear equation and moment equation. So summation of forces vertical equals to 0, considering upward positive. So 14 minus 12 minus B equals 0. So makukuha natin shear is 2 kips or 2 kilopounds. Then sa moment is summation of moment equals to 0, clockwise positive. Then 14, since clockwise siya, so positive x. Then minus 12, then dito yung x minus 4 minus m. Then yung i-simplify lang natin, moment equals 14x minus 12x plus 48. Then combine like terms lang hanggang sa makuha natin to pag sinimplify. Equals m equals to 2x plus 48. So same lang din dito sa for segment C to D. Same lang din. So ang nakuha sa shear is negative 8 kips. Then sa moment naman is 8x plus 168. So sa pag-plot naman ng shear diagram and moment diagram. So since ito yung mga nakuha natin for segment AB is B equals 14, then yung moment naman is 14x. Then segment B to C, ang nakuha natin is B equals 2, then M equals to 2x plus 48. Then dito naman sa C to D, ang nakuha natin is B equals negative 8, then moment equals negative 8x plus 168. So ipa-plot na natin sa shear diagram. So ang dahil lang nakuha natin dito sa segment A to B is 14 and positive 14. So we consider this line as x-axis. So let's say dito yung 14. Then dito naman sa segment B to C, ang shear niya is 2, positive 2. So let's say dito yung 2. Then dito naman sa segment C to D, ang nakuha natin is negative 8. So let's say dito ang negative 8. So dito yung sa shear diagram natin. Then sa pag-plot naman ng moment diagram, dahil 14x to, and yung x natin is dahil dito sa segment A to B, ang x natin is from 0 to 4 lang. So let's say 0 dito, then let's say ang x natin is 4, since yun yung pwede niyang makuha dito, pinakamataas. So 14 times 4, so 56. Let's say dito ang 56. Dito naman sa segment B to C, ang nakuha natin ay 2x plus 48. Ang sa 2x naman is from 4 to 12. So ang minimum niya is 4. Sige, try natin lagay sa calculator yung x equals 4. So 2 times 4 plus 48. So same lang din sa na lumabas is 56 dito. Then pag kinuha naman natin yung highest point, which is yung 12. So 2 times 12 plus 48. So magiging 72. Let's say dito yung 72. Then dito naman sa segment C to D, ang nakuha natin is negative 8x plus 168. So dito naman, ang ano naman niya is 12 to 21 feet dito sa whole length na ito. So pag kinuha natin, let's say ang x is
12. So, 12, negative 8 times 12 plus 168. So, same lang din, 72. Then, pag ginawa naman natin, let's say, yung x is 21 naman here. 21. So, negative 8 times 21 plus 168. Ang nakuha natin is 0. So, bababa siya dito. So, ito na ang magiging maximum moment natin is 72.